All right, let's go. And, well, sorry about that. The computer restarted. So remember that this is a transformation of f of x. So g of x is equal to a times 1 over b times the quantity x minus h cubed. I don't think I need the parentheses in the front there. Well, let me think this through. Yeah, I think I do, yeah? Yeah. Well, the a goes in front of the parentheses, so that's where we have our mistake here. So let me zoom in here. I caught my mistake. So just erase this first little line. And all this stuff here gets raised to the third power plus 4. And so I think there's an error. Well, we'll talk about that in a second. So in this particular case, a is equal to 1 because there's nothing on the outside. B, and I'm going to scroll down here so we have some room. We have 2, but 2 is equal to 1 over b. So to solve for b, what I'm going to do is I'm going to multiply both sides by b. So I multiply this by b, and I multiply this side by b. These b's cancel, and I get 2b is equal to 1. Divide by 2, and I get b is equal to 1/2. So that means this 1 over b equals 2 means that b is equal to 1/2. Okay? H is equal to negative 3 because the formula, in order for you to have a positive 3, you have to have a negative 3, right? So H is equal to negative 3, and then K is equal to positive 4. So the horizontal compression is a factor of 1/2, right? Remember that B was the horizontal compression or stretching. A was the vertical compression or stretching, right? H was left or right, so this is going to be 3 units to the left, and then K was your up or down, since it's a positive 4, it'd be 4 units up. So now over here, this is my parent function, and I'm going to make this a different color. This line right here is the parent function of just x cubed. And you get familiar with it. Whoops, I went a little crazy on there. So this is f of x is equal to x cubed. So on the previous slide and in your textbooks, they say, well, you could plug this in and plug that in, and I don't like that. Why not just plug it in and see what the difference is? And we'll talk about that. So turn on your calculators. I'm going to move this over here temporarily so we can see what we're plugging into the calculators. Going to make my screen big so you guys can see what I'm doing. So here's the parent function, right, in blue. Go to y equals, and we're going to put in the transformed function. What was that transformed function? I think it was 2 times the quantity x plus 3.
Well, cubed plus 4.
Cubed. So I got to make sure you have the right number of parentheses, right? So do it exactly how it is on the thing. To do the cube thing, you hit the caret symbol. This one puts it up in the superscript, then enter in 3. To get out of that script, you hit the right cursor, and then you put plus 4. So let me double check my my slide over here. Yeah, I think that's right. Is that right to you guys? Let me zoom this back over here so we can take a look at it. Does that look right? Yep, that's right, right? Okay, so then I'm going to graph it. And I'm going to take a little screenshot. You guys should probably sketch this. But basically, we're transforming the functions. Okay? So what this looks like, if I stretch this out, and I'll zoom out so you can see everything. Essentially, this point right here, 0, 0, that exists on the original function right here, right? Notice that it also exists over here. We said that we shifted 3 units. It's almost like the vertex, right? So when we've done quadratics, we've had a vertex. When we've had absolute value, h comma k is the vertex, right? So this is almost like the vertex, but technically it's what we call an inflection point. But notice that I went 1, 2, 3 units to the left. Then from here I went up 1, 2, 3, 4 units up. This compression of 1/2 is I'm taking that blue line and I'm making it 1/2 the width. And that's our red function. So we're shifting it up and over, and then we're narrowing it by a factor of 1/2. And that's it. So these are a little bit harder to transform, but not really. And so what does this mean? Well, if I have some values, and I'm going to put this in Desmos, and Mr. Adams is collecting data, right? So I go out into the real world and I collect some data, right? And so I have negative, hold on one sec. Let's say I have -5. Whoops, let me put some numbers in here. Let's say I have -4, comma 60, -62. You're gonna be like, what? That's a lot of stuff, Mr. Adams. Let's say I have the point -2.5, comma, and you can write this down and kind of sketch it because I'm going to do a graph here. But I want you to get the gist of where this stuff comes from. -24. Let's say I have -1.8, comma, -9.1. Let's say I have -0.8, comma 1.1, and let's say I have 0.5 point. You guys should be writing this down somewhere. 0.5, comma 0.1. And let's do 2.3, comma 8.5. And lastly, let's do 3.4, comma 35. So now if I zoom out on this thing, okay, if I zoom out on this thing, oh, this should be a negative. If I zoom out on this thing, what do you notice? It kind of looks like a function, doesn't it? Now, I've got the scaling all funny on purpose, but what it kind of looks like is it kind of looks like a cubic function. So it doesn't matter what the data represents. I go out into the real world, I measure a bunch of data. This is the pattern I see. Well, what I need to do is I need to graph it. So if I say y equals x cubed, that's pretty close, isn't it? Kinda, but I need to transform it. Well, I could say y, let's do it this way. If I say y equals a, right, times the quantity 1 over b, and then I'm not quite done yet, times x minus h, right? I'm going to close that, add this, and then I'm going to raise that to the third power. This is my formula, right? Plus k, add k. What I need to do is I'm going to adjust the values to make that purple line fit the green line. Does that make sense? Or actually, I'm going to hide the green line. And then I'm going to make that purple line fit. Well, we know that b is like 1/2. So I'm going to put that to be like 1/2. And I know that h is -3. And we know that k is +4. Okay. And so basically we just move things around. That's what's going on when we go to changes. Actually, I was doing it to the previous example. But if I move these things around and I move b, I can make it kind of fit. See how that works? Maybe I move this over a little bit this way. See how that works? Maybe I do this. And so that's all we're doing is we're just taking this graph and making it fit the data. That's why it's important to know this. Okay? Any questions on that? Okay, cool. So that's it for now, though. I just want to leave there. I'm going to zoom out, and I'm going to let you guys